So in this second part we'll talk about the steps for solving a circuit or network utilizing Northern theorem. So there are total I think 5 steps there which we have to follow while solving any circuit by Northern theorem. So what is the first step? Remove the load resistance from the circuit. Second is find the internal resistance of the source network by deactivating the constant sources. Third is short load terminal and find the short circuit current. In the fourth step, Northern equivalent circuit is drawn by keeping the internal resistance in the parallel with the short circuit equivalent, and in the final reconnect the load resistance of the circuit across the load terminal to find the current, that is known as load current. So let's start. So for example we have this circuit here, and we have to find Rn In, the current flowing through the load voltage across the load resistor in figure 1 by using the Norton. So we have to find the current flowing through this load resistance. So let's start step by step. So what will be the first step? The first step is to short the 1.5 ohm load resistance as shown in the diagram. So this was the load resistance. First we have to short circuit this. So here all the circuit remain the same, only we short circuit the load resistance and we put A and B terminal here. So what is the second step? In second step we have to find three things. The first thing is we have to find the RT, that is total resistance. Second thing we have to find is the IT, that is total current, and the third thing we have to find is ISC, that is the current through short circuit. So how we will, so let's do one by one. How we will find the RT, total resistance. Now how many resistance are there? There are three resistance, 2 ohm, 6 ohm and 3 ohm. And we see that 3 ohm and 6 ohm are in parallel with each other, and their combined effect is in series with the 2 ohm resistance. So the formula is 2 ohm resistance plus the 6 and 3 ohm in parallel. So we will solve this 2 plus 3 into 6 plus 3 plus 6, and the total resistance is 4 ohm. Now we will find the total current. I is equal to V over RT. What is V? V is our voltage source, that is 12 volt, because we only have one voltage source, so that is 12. And what is RT? RT is 4, we just calculated. So IT will be 3 ampere. Now we will find the final thing in this step, that is ISC. What is ISC? ISC is the current in through the short circuit. We will apply CDR, current divider rule. What is CDR? This is the CDR formula. IN is equal to 3A. What is 3A? Total. So the formula is total current into internal resistance divided by R3 plus Ri. So IT into Ri over R3 plus Ri, that is IT is total current, and what is 6? This is internal resistance. What is internal resistance? Internal resistance, whenever we do the short circuit, so the internal resistance is whatever current will be here on this resistor is also considered as that same current will be here, because they are in parallel to each other. And what is R3? We will always take the resistance that is after this our internal resistance. So we apply the current divider rule. Here we put the total current value into 6 by 3 plus 6, that is 2 ampere. So in this step we find total resistance, total current, and the current through the short circuit. Now we will go the step 3. In step 3, open current source, short voltage source, and open load resistors. Open the current source and short the voltage source. So we have one voltage source. We don't have any current source, so we short the voltage source that is here, and we open the load resistor. Here you remember in first step there was some resistor, load resistor there, so we open this. So in third step we open our load resistor and we short our voltage source. What is our fourth step? Calculate and measure the open circuit resistance. This is the Norton resistance Rn. Now we have to find the Rn. And what is the formula for Rn? That is, here we apply 3 ohm plus 6 parallel to 2. So this is our 3 ohm resistor, this resistor. You remember last time we find the current, we took this resistor and this. So the formula when we are finding the current, now we are finding, calculate and measure the open circuit resistance. This is the Norton. We have reduced 12 DC source to 0 to the equivalent, replace it with a short circuit as shown in the figure 4. We can see that 3 ohm resistance is in series with a parallel combination of 6 ohm resistor and 2 ohm resistor. So we apply with this formula, that is 3 ohm and 6 in parallel to 2. So this is in parallel to this, and we will apply, this is 3 ohm in plus. So our final value for Rn will be 4.5. So what will be our final step? Connect the Rn in the parallel with the current source In and reconnect the load resistor. So this is the final circuit. What values we need here? This is the fifth step. So here we put the total current value, which we find here 2 ampere, which we do here, that is here, the current through the short circuit, because this is short circuit now. So how much current is flowing through it? We put the current source here and we put the current value here. And what is here? That is Rn, that we find from calculate the open circuit resistance. So both values we put here, and now we can see that it is as per the definition of the Norton theorem, that indicates that a current source should be in parallel with the resistance. Now the final step, now apply the last step, calculate the load resistance. You remember we were having here a load resistance in the first step. So we will put that load resistance in this circuit again, that is 1.5 ohm, and we will find the load current through load resistor. How we will find the load current? That is with this formula, In into Rn divided by Rn plus RL. What is In value? We calculated in our previous step, that is 2 ampere. What is the value for Rn? 4.5 in last step we did. And 4.5 plus, what is load resistance value here? 1.5 ohm. So the load current is 1.5 ampere. So load voltage across the resistor, we can find VL also from here. V is equal to IR. I is 1.5 and RL is equal to also 1.5. So VL is equal to 2.25 volt. So let's tally one more time from this. In first step, first of all, we short circuit our load resistance. In the second step, we find total resistance, total current, and current through the short circuit. In the third step, we short circuit our voltage source. In the fourth step, we find the Rn from this formula. In the fifth step, we draw the Norton equivalent circuit, that is current through the short circuit and in parallel with the total resistance, that is Rn, that we find out in our previous step, that is 4.5. And in the final step, we include our load resistance